Let me start with the real-world problem before the definition. You are building an e-commerce app on Azure. Users upload product images. Order confirmations get queued for async processing. Session data needs fast key value lookups. Old invoices need cheap long-term storage. Where does all of this go? It goes into a storage account. An Azure storage account is not a single storage type, it is a namespace, a container, that holds 4 different storage services under one roof. You provision a storage account and inside it you can use Blob storage for files and images, queue storage for messaging, table storage for structured NoSQL data, and file storage for shared drives that mount like network drives. Every storage account gets a globally unique name, and that name becomes part of the URL for every piece of data you store. If your account is named mycompanistickery, your Blob endpoint is mycompanistickery.blob.core.windows.net. One thing to know immediately, all data in Azure storage is encrypted at rest by default using AES-256 encryption. You do not configure this, it is on from the moment you create the account. This is table stakes for cloud storage today, and Azure handles it transparently. A single storage account gives you access to 4 completely different storage services. Understanding which one to reach for is a core developer skill. Blob storage is for unstructured data, anything that is a file. Images, videos, PDFs, log files, database backups, machine learning datasets, static website assets. Blob stands for binary large object. You organize blobs inside containers, which are like top-level folders. This is the service you will use most. Queue storage is for messages between loosely coupled application components. When a user places an order, your web API drops a message in a queue. A background worker picks it up and processes the payment. The web API does not need to wait. Queue messages can be up to 64 kilobytes and can be retained for up to 7 days. Azure Table Storage is a NoSQL key value store with a schemaless design. It is very fast and very cheap for simple lookups by partition key and row key. Good for device telemetry, user session data, or any scenario where you have a known key and need the value quickly. For more complex query patterns, Cosmos DB is the better choice. Azure Files provides SMB and NFS file shares that mount to both Windows and Linux machines. The primary use case is lift and shift migrations where existing applications depend on a shared network drive. You replace the on-premises file server with Azure Files without changing the application. Microsoft offers several account types and picking the wrong one is a mistake you cannot easily fix later, since you cannot change a storage account type after creation. Standard General Purpose v2, or GPv2, is the default and the right choice for most workloads. It supports all 4 storage services: Blob, Queue, Table, and Files. It uses HDD back storage, which is fine for most applications. If you are not sure which type to pick Standard GPv2. Premium block blobs are SSD backed and designed for high throughput, low latency blob scenarios. If your application is doing tens of thousands of small blob read and write operations per second, think real-time analytics, ingestion, or interactive applications, this tier gives you sub-millisecond latency. The trade-off is cost. Premium is significantly more expensive per gigabyte. Premium file shares are SSD-backed SMB and NFS shares. Use these when you are lifting and shifting enterprise applications with strict IOPS requirements on their shared drives. Premium page blobs back Azure Virtual Machine managed disks. You generally do not create these directly, Azure manages them when you create a VM. For most developers building web applications, APIs, or data pipelines, standard GPv2 is the correct choice. Azure automatically replicates your data for durability. You choose how much replication you want, and that choice directly affects your cost and your recovery capabilities. LRS, locally redundant storage, makes 3 copies of your data within a single data center. It protects against drive failures and rack failures but not against a data center going down. It is the cheapest replication option. Use it for development environments or data you can regenerate if needed. ZRS, Zone Redundant Storage, spreads 3 copies across 3 availability zones in the same region. If one data center in the region has an outage, your data is still accessible from the other 2 zones. For production applications in a single region, ZRS is the minimum I recommend. GRS, Geo-Redundant Storage, combines LRS in your primary region with an asynchronous copy to a secondary region hundreds of miles away. This protects against a complete regional disaster. However, you cannot read from the secondary region during normal operations, only during a Microsoft-declared failover. RAGRS, Read Access Geo-Redundant, gives you read access to the secondary region endpoint at all times, not just during failovers. This is valuable if you want to serve reads from 2 regions for lower latency or want guaranteed read availability even if the primary region has issues. GZRS combines ZRS in the primary region with georeplication, the most comprehensive protection available. Azure Blob Storage has 4 access tiers that let you balance storage cost against retrieval cost. Understanding tiers can cut your storage bill significantly for the right data patterns. The hot tier is for data you access frequently. Think active user uploads, application assets being served on every request. Hot storage has a higher per gigabyte storage cost but the lowest cost per read and write operation. For frequently read data, this is what you want. The cool tier is for data you access infrequently, at least 30 days between accesses. Think monthly reports, infrequently viewed old images, application logs you keep for compliance but rarely query. Cool storage costs less per gigabyte but charges more per operation. Data stored in cool for fewer than 30 days incurs an early deletion penalty. The cold tier is newer and sits between cool and archive for data you access roughly every 90 days. Storage cost is lower than cool, but retrieval cost is higher. Archive tier is for data you almost never access but must retain. Think 7-year compliance archives, decommissioned database backups. Archive is the cheapest storage per gigabyte by far, but blobs in archive are offline, you cannot read them immediately. Rehydration, moving a blob back to hot or cool, takes 1 to 15 hours. Lifecycle management policies let you automate these transitions. Define a rule: after 30 days, move to cool. After 90 days, move to cold. After 1 year, move to archive. Azure applies these transitions automatically without you touching each file. Storage security is where I see the most developer mistakes, so let me be direct about what to do and what never to do. By default, when you create a storage account, all containers are private. No one can access your blobs without credentials. That is the correct starting point. Connection strings contain full account access keys. They look like a long base64 string and give whoever has them complete control over all data in the account. I see connection strings hard-coded in GitHub repositories every week. This is a serious security vulnerability. If a connection string gets exposed, anyone with it can read, modify, and delete all your data. Never put connection strings in source code, never check them into Git. SAS tokens, shared access signatures, are time-limited, scoped access URLs you generate programmatically. You can create a SAS token that allows read-only access to a single blob for the next 2 hours. When those 2 hours are up, the token stops working. Use SAS tokens when you need to give temporary access to a specific resource, for example, to let a user download a private file. Managed identity is the best practice for application authentication. When your app service or Azure function has a managed identity enabled, it gets an identity in Azure Active Directory. You grant that identity the storage blob data reader or storage blob data contributor role. Your application code calls the Azure SDK using default Azure credential, no connection strings, no secrets in code at all. Azure handles the token exchange invisibly. This is the approach I strongly recommend for all production applications. Let me show you how to actually create and use storage accounts in both the portal and CLI. In the portal, search for storage accounts, click Create. You choose your subscription, resource group, and give the account a name. Storage account names must be globally unique. There is only one namespace across all of Azure, and names can only contain lowercase letters and numbers, 3 to 24 characters. Microsoft validates uniqueness in real time as you type. Then choose your region, performance tier standard or premium, and redundancy. For most workloads, start with standard and LRS in development, ZRS in production. With the CLI, the command is az storage account create, with name, resource group, and SKU. The SKU combines the performance and replication tier, standard_LRS, standard_ZRS, standard_GRS. After creation, create a container, az storage container create with a name and the account name. Containers are the top-level folders for blobs. To upload a file, use az storage blob upload. Pass the file path, container name, and account name. You can optionally specify a blob name. If you do not, it uses the file name. For a basic test, az storage blob upload with a small text file and then az storage blob list to confirm it uploaded correctly. For authentication in CLI commands, you can pass the account key directly for quick testing, but for scripted pipelines you should use az login or managed identity so no secrets are embedded in scripts. Azure Storage Explorer is a free desktop application from Microsoft that gives you a visual interface for working with storage accounts. Download it at storageexplorer.com. It runs on Windows, Mac, and Linux. When you open it, sign in with your Microsoft account and Storage Explorer immediately lists all storage accounts across all your subscriptions. Expand any account to see its blob containers, queues, tables, and file shares. You can upload files by dragging and dropping. You can download entire containers. You can set metadata and access tiers on individual blobs. You can generate SAS tokens with a right click. One particularly useful feature is connecting via SAS token. If a colleague gives you a SAS URI for a container in their subscription, perhaps for sharing large files during a deployment, you can paste that URI into Storage Explorer and browse it directly, even though you have no subscription access to their account. For local development, Storage Explorer connects to Azurite, which is the Azure Storage Emulator. Azurite runs locally and emulates the blob, queue, and table APIs. You can develop and test your storage code without making any real Azure API calls or incurring any costs. Then when you promote to staging or production, you swap the connection string for the real account. Azure Portal also includes a built-in storage browser panel that gives you similar capabilities without leaving the browser. For quick checks and small uploads it works well. For serious data management work, the desktop app is more comfortable. Storage costs are deceptively easy to ignore until the bill arrives. Lifecycle management policies are the tool that keeps costs under control automatically. A lifecycle rule is a JSON policy you attach to a storage account that says, for blobs in a certain container, matching a certain prefix, apply this action after this many days. The actions include transitioning to cool, transitioning to cold, transitioning to archive, and deleting. You can base the age calculation on creation time or on last access time. The latter requires enabling access tracking. A common pattern for application logs, blobs in the logs container move to cool after 30 days, move to archive after 180 days, and get deleted after 365 days. You write the policy once and never touch those logs again. Azure handles every transition automatically. You can also use lifecycle policies to clean up old blob versions and snapshots. If you enable blob versioning, which creates a new version every time you overwrite a blob, old versions accumulate and cost money. A lifecycle rule that deletes versions older than 90 days keeps version history without unbounded cost growth. Soft delete is worth enabling in production. It gives you a configurable retention window, typically 7 to 30 days, during which deleted blobs can be undeleted. This is protection against accidental deletions or application bugs. The cost is minimal, you only pay for the storage of the soft deleted blobs during the retention period. Monitor your storage costs in Azure Cost Management, filtered to the resource group or storage account. For large-scale storage, also check the Storage Account Insights blade for access pattern analysis that can inform your tier choices. Let me tie this together with the patterns you will actually use in real applications. Static website hosting, enable it on a storage account and upload HTML, CSS, and JavaScript files to the $web container. Azure serves them as a website at a public URL. The cost is pennies per month for a static site, no web server, no managed hosting fee. Pair with Azure CDN and a custom domain for a production-grade static site. App Service and Azure Functions write application-generated files to Blob storage, not to the local file system. App Service instances are ephemeral, they can be recycled at any time, and local disk state is lost. If your application generates reports, uploads, or exports, write them to Blob storage immediately and return a download URL to the user. Azure Data Lake Storage Gen 2 is Blob storage with a hierarchical namespace enabled. This is the storage layer for big data analytics. Azure Synapse, Azure Databricks, and HD Insight all read natively from ADLS Gen 2. If you are building data pipelines, enable the hierarchical namespace when creating the account. Blob triggers with Azure Functions create powerful event-driven pipelines. Every time a blob is created in a container, a function is triggered. Upload a video file, the trigger fires, the function kicks off a transcoding job. Upload a CSV, the function parses it and writes records to a database. This pattern replaces polling loops with instant event-driven processing. Finally, for cross-service access, always use managed identity. Grant the storage blob data contributor role to your app service, function, or AXPod identity. No connection strings stored anywhere. Azure handles token refresh automatically. Clean, secure, production grade. Great question to think about. Your app service needs to write blobs to storage. The wrong answer is a connection string or account key in your app settings or source code. The right answer is managed identity. Enable system-assigned managed identity on the app service. Then go to the storage account's access control and assign the storage blob data contributor role to that managed identity. In your code, use default Azure credential from the Azure Identity SDK. When the app runs on app service, it automatically gets a token from Azure Active Directory. No secrets, no rotation, no leaks. Active recall, thinking before seeing the answer is how real learning happens. If you got that right, you understand the most important security principle in Azure storage.